Hello my dear children, this is my next chapter of the chemistry, that is electrochemistry. After solution, we have completed the chapter solution. Hope you have learned the chapter thoroughly, and I have sent the assignment of the chapter solution, and within days I will send you the complete assignment and more of the, that is numericals. You solve those, and if you have any problem you can send me at my mail ID. Now write down your next lecture is of electrochemistry. Very interesting chapter it is. After solution, write down electrochemistry is a branch of chemistry. It's a branch of chemistry which deals with the study of two types of reactions. In one of the reaction, chemical energy converted to electrical energy, chemical energy converted to electrical energy, and in other vice versa, electrical energy converted to chemical energy. So in this chapter we will study, very interesting chapter it is, but do my work regularly. Only then the chapter depth will get clear. We will study two types of reactions. Chemical energy converted to electrical energy in a cell. Write down electrochemical cell. Electrochemical cell. And electrical energy converted to chemical energy in a electrolytic cell. In a electrolytic cell. Now in electrochemical cell, the current is carried by electrons and ions, both. But in electrolytic cell, the current is carried by ions only. In a very slow manner you can write. It's a very interesting chapter, but understand deeply. So this is a chapter where we will study two types of cell, electrochemical cell and electrolytic cell. So main chapter, 80% chapter has electrochemical cell, just 20% chapter concepts from electrolytic cell. So today we are going to start electrochemical cell, but before that, listen. In this cell, electrochemical cell, the current is carried by electrons and ions. But in electrolytic cell, the current is carried only by ions. Now, when the current is carried by electrons, when the current is carried by electron, it is called electronic conductance. Electronic conductance. And when the current is carried by ions, it is called electrolytic conductance. Hence there are two types of conductance. Here the current is carried by electrons, here flow of electrons, and here flow of ions. Right. Now second, this conductance takes place without any decomposition. Without any decomposition of electrolyte. Electrolyte is a solution from which electricity can easily pass. So without any decomposition. You know, metals are metals. Example, metals are good conductor of electricity, but when current is carried by metal, metal never decompose, metal never break. In metal there are loosely held electrons which carry current without any decomposition. Metal carrying current, but because there is a ions, and you know ions only then form when something get decomposed. ABE is dissociated, only then ions form. So this electrolytic conductance takes place with the decomposition of electrolyte. without and with. Because ions only then formed if something dissociate. Otherwise ions will not form. So this is one of the, let it is some NaCl. So NaCl is a poor conductor, it's a bad conductor of electricity until it break up into sodium and chloride ion. It break up to give ions. When the ions form, then the ions will carry current. But that is NaCl is solid form, not conductor. But the moment it is dissociated in molten and in aqueous form, it is dissociated to give ions. Ions carry current. So ions formed only then if decomposition takes place. Third number. So electronic with electrons, electronic without any decomposition. And you know metals never decompose, metal never dissociates, carrying current, but ions only then formed if dissociation takes place. And the last is third. This conductance decreases. This conductance decreases with the increase of temperature, and this conductance increases with increase of temperature. It decreases, it increases. The question is why it decreases. The conductance decreases with the rise in temperature. I am making a diagram. For example, I have a sodium metal. Sodium, let it is a sodium. Sodium is 2, 8, 1. This is inner shell. Sodium, 2, 8. Sodium. These are sodium inner shell. Sodium. Okay, and 1 is outer. This is a mobile electron. Electron is a mobile, free. This is electron in the metal. You know, in the metal, electrons are mobile, but this inner ionic part is fixed. It's a fixed. These electrons are mobile. The moment you increase the temperature, of the metals, this fixed ionic kernel, they start vibrating. These fixed ionic kernel start vibrating, and hence they produce a obstruction, that is restriction, that is hindrance in the movement of electron. So electrons now not able to move freely. Why? Because you have increased the temperature. When the temperature increases, these fixed ionic kernel, they start vibrating, and hence produces obstruction in the movement of electron. When the electron will not move, how the current will carry? So that's the reason it decreases. Temperature increases, fixed ionic kernels start vibrating, they produces hindrance but in this case it increases with increase of temperature. Why? Because this conductance depend upon 3 factors. A part, viscosity, right? What is a viscosity? Viscosity is a force of interaction between a solvent and solvent. Viscosity. B part. B part is solvation of ion. B part is interionic interaction. Interionic interaction is between solute and solute. Interionic interaction. And the C part. C part is solvation of ion. Solvation of ions. The solvation of ion is between solute and solvent. Right? So these 3 interactions become weaker. When temperature increased, more the temperature, forces break. The ions become free to carry current. Forces break. Force of interaction weakens. Free. Now they carry current. So that's the answer. I'm repeating my topic again. After that, we are going to start the chapter. This is introduction of the chapter completed. So what we have done, electrochemistry is our next chapter. In electrochemistry, we will take the electrochemistry chapter. There is 2 types of chemical reactions. That is, one is chemical energy to electrical energy, the other is electrical energy to chemical energy. Chemical energy to electrical energy in a electrochemical cell, electrical energy to chemical energy in a electrolytic cell. Today we are going to start electrochemical cell. Electrochemical cell we are going to start. So in electrochemical cell there is a flow of electrons and ions. So what we have discussed? We have discussed both flow. Electron flow is electronic conductance, ions flow is electrolytic conductance. And what were the differences? Flow of electronic, flow of electrons. During electronic conductance, nothing decomposed, and electronic conductance always decreases with increase of temperature. And what would electrolytic conductance? Due to ions, and ions only then form if something dissociate, and if dissociation only then ions form. So temperature increased, force is increased, ions become free. This is introduction. Okay, let us start your chapter now. Electrochemical cell. Write on. This is also called galvanic cell, galvanic and voltaic cell. You can open your NCERT book even, but more clear points will be here. In NCERT language is difficult, so you take the help of both, right? Electrochemical cell, galvanic cell, voltaic cell. Their discoverer names, Lord Galvani, Volta. Now I'm taking in detail. You go on making a diagram along with me. Remember student, whatever the diagram I will make, whole chapter, 80% chapter depend upon this diagram. So basic, take the basic understanding of the diagram from here. Draw along with me, right? Make two beakers. Draw along with me. Only then it will become more clear. Take two beakers. Roughly you can make. In one beaker you take zinc sulfate. In other beaker you will take copper sulfate solution. In zinc sulfate solution you put zinc plate, right? Zinc plate. In copper sulfate solution you put copper plate, right? First time construction it is going on. Connect these two plates with a wire, connecting wire. And this is your galvanometer, G, galvanometer, right? Now what is this? In this there is a U-shaped tube. You can make a U-shaped tube in the lab. U-shaped tube. In the U-shaped tube there is filled highly viscous material, highly viscous, VISCOUS, highly viscous material of inert electrolyte. Electrolyte must be inert, should not react with anyone. It is your salt bridge, remember this, salt bridge it is. And what is inside? In a label all things, KCl or KNO3, inert electrolyte. Write each and everything along with me, inert electrolyte. Okay. Close is two ends with the cotton or glass wool. Close is two ends, close. I think construction completed now. Again listen, two beakers, zinc sulfate carrying zinc plate, copper sulfate carrying copper plate. Join these two plates with the wire, galvanometer in the middle. This is your salt bridge, okay? This is your inert electrolyte, very viscous it is, never flow like your ordinary liquid. It's a cotton filled, that is ends closed with cotton and glass wool. Let us start. After some time, write down observations. Write down observations. Observations. What see you will after some time. First number. Draw a diagram along with me, right? Write and make a diagram. Zinc plate, see, zinc plate loses the weight. Zinc plate loses the weight. and at the same time weight, W-E-I-G-H-T. At the same time, copper plate gains the weight. Simultaneously, copper plate gain the weight. Zinc plate loses the weight, copper plate gain the weight. And very important, third point, only 3 observations. Third, you see, galvanometer needle deflected towards right hand side. The needle get deflected towards right hand side. These are the 3 observations. So we will analyze this, what is going on. After some time you will see 3 observations. Zinc plate loses the weight, copper plate gains the weight, and galvanometer needle deflected towards the right hand side. The question is why? I think you must have written. Now I am taking in detail. Why result? Write down the result now. Result. Zinc plate loses the weight because of oxidation. Oxidation is a loss of electron. Oxidation is. Zinc plate oxidizes. Label. This beaker is now called oxidation half cell. Oxidation half cell. Right now. This is zinc plate oxidized, and this is the reason zinc plate loses the weight. Zinc plate loses the weight due to oxidation, and where these ions comes, when zinc plate loses the weight, these ions come into solution. Right? Make the ions. These ions come into the solution. Okay? And where these electrons? These electrons will go this side. This needle deflection show electrons are moving this side. Electrons movement, right hand side. These are the electrons. Label it, kindly label it. Electrons are moving inside. From the zinc plate, they are moving towards copper plate. Electrons here, electrons. Enter into the solution. Action started. Copper ions in the solution is a copper ion. Copper ion gains those electrons simultaneously. It becomes a copper. This copper get deposited here. Copper ions of solution gains the electron released by zinc plate, and reduction takes place inside the solution. And after reduction, copper metal deposited over copper plate. So that's the reason this plate gains the weight. And again listen to me. Zinc plate loses the weight due to oxidation, and this cell is called reduction half cell. Reduction half cell. Right? So zinc plate loses the weight because oxidation takes place. Zinc ions come into the solution, and there's where these electrons go. These electrons go by this wire and this wire and enter through the copper plate. Enter in the solution. In the solution, copper ion is there. So this is all about, this is copper, and copper deposited here. Now this is, you can add these two equations, cancelling electron. This is a net reaction going on. Zinc plus, copper 2 plus, arrow zinc 2 plus copper. Now the side where the electrons are moving, that is this side, right hand side, the copper plate, right now, acquire high potential. It acquire high potential, and zinc plate acquire low potential. Hence a potential difference created. So current started flowing from high potential to low potential. Current, electrons, write down. Electron move from this to this zinc plate to copper plate, and current moves from copper plate to zinc plate. That's the reason this is called electrochemical cell. Electrochemical cell. Why? Because a chemical energy, that is zinc plus copper 2 plus, arrow zinc 2 plus, reaction going on, current producing, a chemical energy converted to electrical energy, current. Chemical energy, reaction, that is electric energy. Now named, scientists named it anode. Remember students, very important, the plate which oxidized named anode, and the plate which reduced is always cathode. If anybody asks you what is anode, your answer is anode is that where oxidation takes place, and cathode is that where reduction takes place. So this is anode, this is cathode. Now the very, very important point is anode is negatively charged, very important, and cathode is positively charged. Question is why? Anode is always positive and cathode is negative. No student, this is electrochemical cell. That cell is you are doing first time. Why? Question is why anode is negative? Why we have given the negative polarity to the anode? Why? Because this plate oxidized, zinc ion come into solution, and electron go here. Here's a cluster of electron. This end is rich in electron. Electron have a negative charge. So this acquire negative polarity, and this end is waiting for electron. This end is deficient of electron. This is waiting, electron, that is wait for electron. When the electron will come, only then the reaction will start. So this end is electron deficient end. This reaction only then starts when the electron will reach there. So this is demanding electron deficient end, so acquire positive polarity. Electron rich end, electron deficient end. Electron rich end is negative. Why? Because electron is negatively charged. Electron deficient end is always positive. So this is positive end. This is complete reaction going on, and this is this reaction, that is half reaction we have done, complete reaction we have done. Very important again. Flow of electron, remember now, flow of electron always from anode to cathode, and current always flow from cathode, right? Anode to cathode, always electron flow, and current flows from cathode to anode, current. Electron flow from anode to cathode, current flow from cathode to anode. So this is electrochemical. So the question is now left is, why salt bridge is there? What is the role of salt bridge? You make a heading, role of salt bridge. Make a heading on your notebooks, role of salt bridge. Now student, do you know, when the zinc plate oxidized, lot of zinc ion come into solution. Zinc ion. Lot of zinc ions come into solution. This means this solution acquire lot of positive charge. Zinc ions, and there is sulfate ion. I know sulfate ion, maximum sulfate ion. Where is copper? Copper reduced, deposited here. This beaker is full of zinc ions. This beaker is full of sulfate ions. Or you can say this beaker has excessive positive charge, and this beaker has excessive negative charge. Equal charges repel each other. When the excessive positive charge will be there, then it will refuse to take more of zinc ion, send back. It will also refuse to take more of electron, because sulfate is negatively charged, so it will not allow the electrons to enter here. So after some time the reaction will stop. That is, cell will stop working if the salt bridge is not there. It will work for a few minutes, but when there is a collection of zinc ions and collection of sulfate ion, the cell will stop working. But in the presence of this, cell always go on working. How? The moment there is excessive zinc ions, then the salt bridge releases chloride ion. Write down Cl minus. This side potassium ion, K plus. Inert it is, inert electrolyte it is, so no obstruction to any of that is chemical, just it will come to neutralize the charge. So you can write in one line, salt bridge maintain the neutrality of two solutions. You can write in one line, salt bridge maintain the neutrality of the two solution by sending its negative, no need to write this, just half line is sufficient. Salt bridge maintain the neutrality of the two solution. Just if you want to expand the line, by releasing negatively charged ion in oxidation half cell and positively charged ion in reduction half cell. Now student, this is your electrochemical cell, and remember its voltage is 1.1 volt when it is working, and it's represented by zinc. This is zinc. Make a line, single line. It is converting to zinc 2 plus. It's very important thing going on. Now make two lines vertical. It's a salt bridge. Two vertical line is salt bridge. Next copper 2 plus. Your copper ions converting to copper. Single line. Make zinc solid. You can write solid, zinc with solid. Zinc 2 plus aqueous. Copper 2 plus aqueous AQ. Copper is solid. And the concentration of zinc ion is 1m. 1m, only then the voltage is 1.1. 1m, must write. So remember, this is very important question, representation of Daniel's cell. Again listen, zinc solid, single line, straight single line, zinc 2 plus aqueous, 1m, concentration 1m, two vertical lines, salt bridge, representation of salt bridge, copper 2 plus aqueous 1m, single line, copper solid. This is going on. Zinc converting to zinc ions, copper ions converting to copper. Now one thing left, just 1 minute I will take. Now you can please open NCERT. It's time to open NCERT now. This is electrochemical cell. If, very important now, this is, question is, if you apply, now there are 3-4 diagrams are given in the NCERT in the first page. There are 3-4 diagrams are given. You just check the diagram, only to check it, because 1 mark question is set from these diagrams. If to this cell external voltage is given, external voltage is given of 1.1 volt. External voltage, battery is here with voltage supplying 1.1 volt connected to it. Answer is nothing happen. It's 1.1, external is 1.1, nothing will happen. A part. But if it's less than 1.1, then same type, that is current flow from copper to zinc, electron flow from zinc to. But if the voltage is greater than 1.1, if the external voltage is greater than 1.1, remember student, then vice versa takes place. Current flow from anode to cathode and electron flow from cathode to anode, vice versa. And this become an electrolytic cell now. Electrolytic cell now. 3 diagrams you can check. Just 1 mark question may set from there. What will happen if this to this? The voltage supplied is 1.1, nothing. Cell will not work. No current will flow. No reaction will take place. Less than 1.1 reaction, this reaction is going on, that we've done. Same reaction, that is current flow from anode to cathode, electrons flow from anode to cathode and current flow from cathode to anode. But if the voltage is greater, then vice versa will take place. I think this is sufficient for today's lecture. Same with the same diagram, we'll start the next topic tomorrow. So this is all about, so my request to all of you, draw a diagram, mark each and everything, label each and everything, and think deeply what this electrochemical cell giving us the knowledge. Chemical energy converted to electrical energy. Okay, so this is all about. Kindly listen my all lectures completely. Do my assignments regularly, whatever I am going to deliver the assignments. So this is all about next lecture, next time. Thank you.